years ago, I was in your seat. Should I go to grad school? So what I'm going to do is I'm going to talk about what grad school is all about, talk about the different types of degrees, which you may have already seen before. So was everyone here when Roby Polikar came? Yes? Yeah. So Roby Polikar was my advisor for my master's degree. He's my co-advisor for my PhD. He is been on my candidacy committee, and I'll talk about that. And he's also on my doctoral dissertation committee. So it's been there a while. So a little bit about myself, and as I said, we'll talk about the PhD. I'll tell you what a day in the life of a grad student is like, and then I'll give you some tips if you're thinking about it, or just some suggestions that you should consider if grad school is in your future. So currently, I'm a PhD candidate. I don't call myself a student anymore. I'm a PhD candidate in the Department of Electrical and Computer Engineering. I started in July of 2011. Prior to that, and so I'm in the EC department. Prior to that, I did my ECE degree, the Master's of Science at Rowan University, so it took me about 2 years. And just as I said before, a few years before that, I was actually sitting in your seats wondering if grad school was going to be for me, and obviously it has because I'm going for the PhD. A little bit about my history of employment. I have been in academia most of my life, if it isn't clear. But I started out at Cortec. Is there anyone here from Cortec? No one here from Cortec? No? So I started out as an intern for a year. I was hired full-time as an engineer, and they knew I was going to leave in a year. So a year later, I had left to go to Rowan University, and what's been paying my way was a research assistantship that I received. I'll talk a little bit more about that. I was hired as an adjunct professor, so I taught a course which would have been equivalent to the second half of Al Macy's analog systems, so solving electrical circuits with capacitors, inductors, and we're looking at solving circuits with differential equations, Laplace transforms, and phasors and all that fun stuff, so everybody remembers that. Right now, I'm a research and teaching assistant at Drexel University, and that'll probably continue for another 2 years or so until I finish. So what we're going to start out doing here is I'm going to talk about the different types of degrees, what's going on with each one of them, and we'll get into a little more details, and then we'll start talking about specifics and what grad school is all about in terms of the research. So there's a Master's of Engineering, which is typically 30 to 45 credits to get. It's all coursework, and usually you see a project to finalize the degree. So that's what I'll finish at. There is a Master's of Science, which is again generally 30 to 45 credits. However, it's not all about classes anymore. So you'll take fewer classes, which sounds great as a student, and you just do more what would be equivalent to courses in terms of research credits. So you work on a project that's very focused, very specific, and at the end of it, you'll give a thesis defense. You'll have this big, long, 100-page paper that shows a culmination of all the work that you've done for about, an entire quarter on a specific problem that interests you. So a thesis is more rigorous than any project that you would ever see coming from a Master's of Engineering. And then there's the third degree, which is much different, which I've highlighted in green. It's different than either one of those two because it's not about coursework. It's not about taking classes, although you do have to take some. It's all about research. It's about 90 credits. It takes about 4 or 5 years, sometimes 7, up to 10 years to get. So it takes a very, very long time to earn a PhD. It's generally 90 credits. Nearly all of it's research. Most of the time, once you get past the Master's of Science with the PhD, you won't take classes anymore. You'll be done with it. And it all becomes about your research at that point in time. Thesis is most definitely going to be a requirement. So you're going to have to get up and give a dissertation. And it comes with 3 general milestones, and I'll talk about them a little bit later. You have your qualifiers, you have your proposal, and then you have your defense at the end. The proposal is probably the most intense one of those. So the Masters of Engineering, if you're not familiar with it, it's all coursework, as I said, but it's generally geared more towards somebody who is currently working and the company is paying their way to get through. So if you want to be a practicing engineer and you want to pick up a master's degree along the way and your company says, hey, we'll pay for it, this might not be a bad way to go about doing it. However, if you think the PhD is in your future, this is not the route you want to go because it lacks any research. It's all about taking courses, much like an undergraduate degree is. It's all about taking classes. That's what it is. Whereas the Master's of Science has research credits associated with it. Funding is generally going to be very difficult to obtain here because there's no research involved. Because there's three different types of institutions that you see. You see educational institutions, you see institutions that are about a 50-50 split with education and research, and then there's the very, very large institutions like the University of Pennsylvania and Drexel, which is primarily research, and then the education is a much, much smaller portion of it. Which, if you're interested in going to PhD, that's a very, very good thing. But the funding is difficult because when funding comes in, it's generally going towards PhD students who are going to be working on research grants. And engineering, and Master's of Engineering, if you're working on classes, you're not working on research. So essentially, you take the classes you want until you meet your requirements, and then you're done. So there's no research required. The Master's in Science is going to be a little bit more research-oriented. It's not going to be as intense as the PhD, but you'll take your courses, you may take, instead of 10 courses, you'll take 7 courses, depending on where you go. And then you take a little bit of research credits. And generally, the Master's of Science is picked up along the way until you get the PhD. So it's just something that happens. It usually happens around the time you take your qualifier exams. So the idea here is fewer classes, more research, but you get the, it's not a better degree, but it's, if research and academia is in your future, it's a more advantageous degree to take. Many companies may actually rank the Master's of Engineering and the Master's of Science equivalently because they're both master's degree. However, that's generally not the case in academia. So as I said, if you're looking at doing your PhD, you want to have a Master's of Science. And the reason is because a PhD is a research degree. So you want to go in there showing that you can do research, you're successful at it, and if you're successful at research, generally you'll be a good PhD student and a good PhD candidate at that point. A thesis defense is generally required to graduate, so you spend all this time doing this research, you write this big long paper, you give a presentation for about 40 minutes, they tear you apart, and then you either graduate or you have to do it again, which usually you don't want to do it again. You only schedule that defense when you're absolutely certain you're going to get by. Funding is generally more readily available because now your education now has research associated with it. And I keep saying research over and over again. And I'll go over in a couple of slides what I actually mean by that, because it's a little bit different than looking at how you deal with your undergraduate degree and you're taking courses. So I think the cool thing about the Master's of Science is that A, you have a master's degree, which is great, but you get to kind of get your feet wet with research and you get to work on a problem that's generally open-ended and it doesn't have a solution. And I think that's pretty cool. You can find these problems, you can develop these problems that no one has an answer to. You can look in the back of your DSP book and look for really, really hard questions to solve, but the point is that somebody knows the answer to one of those problems. With research, that's not the case. You may have an idea about how to solve a problem, but it's not like you can go to any textbook in any library or any piece of literature that's out on the IEEE's Explorer's website and find a solution to the problem. So I think that's a pretty cool thing about this concept of working on a research-driven project as opposed to just taking classes. But it's a different type of problem that we're working on. So why would you consider going for a Master's of Science or a Master's of Engineering? I would say the big things are going to be better pay, better starting positions, more responsibility, and it's easier to advance. However, that is kind of conditional on you not being lazy. And the reason you would say why you're going to get better pay, better starting positions, if you have the Master's of Science, you've already shown that you can work independently on a problem, and you can develop a solution to that problem. And if they wanted to say, well, what'd you do? You have your master's thesis, you have your defense and everything that you prepared for that you can show them, or to show a future employer. And generally, the Bachelor's of Science and the Master's degree will look better than someone applying for a job that just has a Bachelor's of Science. So it's fairly advantageous to get it. And they're a lot of work. There's a lot of work to get a graduate degree, but it will pay off in the long run, for sure. And another reason to go for it is if it's going to help you get ahead or achieve a goal. So if you want to work on a problem that I don't have a solution to, and no one else has a solution to, that's in a field that you're very interested in, that's a reason to kind of look at going after a Master's of Science, but you don't think that research is going to be in your life completely. Or perhaps maybe a position at a company requires a Master's of Science, getting one would allow you to take that position. Okay, so getting a master's degree, you're going to work longer hours, you're going to work a lot harder, but you're still going to have plenty of free time and to keep your mind active and do what you want to do. When you start to go towards the PhD route, you're starting to look at research as becoming a very, very large part of your life in terms of working on it a lot and just the amount of time that you spent on your free time is now spent researching other areas and continuing your research. So we've kind of discussed the Masters of Engineering, the Masters of Science, and kind of what goes into them. And I've been throwing this word research around a lot. So now it's kind of time to talk about the PhD and what actually goes into this idea of research. And the PhD, as I said, it's different than the Masters of Science and the Masters of Engineering with one point. It's all about the research now. You'll take classes, and that's fine, but when it comes down at the end of the day, what it's going to take to get a PhD is research. It's about presenting your work, doing your work, presenting your work, and having it accepted at conferences and journals. And that all culminates to the end to actually get your PhD. So the degree is definitely, it's not for everyone. Yeah, I think most people can go out there and get a master's of engineering or a master's of science, and they can move on and get a very, very good job. But the PhD really requires that you're very, very, very persistent. You can't stop because there's a lot of milestones. There's 3 big milestones that you have to pass in order to get it. So there's fewer classes that you're going to take. As I said, you only generally take maybe what would be required of a Master's of Science. And then past that, it's all research credits from there. And there's 3 different milestones that we generally encounter with the PhD. There are the candidacy exams, some people call them qualifiers, the proposal, and the defense. So as I said, I'm a PhD candidate, and the way candidacy works is varies from institution to institution, but generally there is some type of test, whether it be a written test or an oral examination, where you go up in front of a committee, you research a topic, you present it to them. You have to have some original piece of material that builds on top of all those other topics. You go up in front of a committee, they tear you apart for an hour, and at the end of it, you either become a PhD candidate at that point, which pretty much says you're on track to graduate, or you have to take the qualifier again. And generally you have 2 shots. So at the end of the second shot, if you don't have if you have not passed candidacy, they'll generally ask that you leave the program and just finish with the Masters of Science. So that's a very big hurdle to get past, but one of the biggest ones I would say is the thesis proposal, which is what's going to be, this is what I want to do my dissertation on. So it's going to be critiqued very heavily by your committee to make sure that you have a very, very strong idea before you move on. And then if you get to the point where you're looking at doing a defense, generally your advisor won't let you schedule that defense without being extremely confident in you. And as I said, it takes 4 to 5 years to get this, maybe longer, maybe up to 7. Whereas the Masters of Science and Masters of Engineering, you can usually pull that off in a year and a half or 2 years. So the PhD is definitely a very large time commitment, and it is a different type of degree than the Masters of Science and the Masters of Engineering. Okay. And generally, funding is more readily available to PhD students. It's not to mention that it's not available to Masters of Science. I was funded through a research assistantship at Brown University. And at Drexel, I'm also funded through a research and teaching assistant, which essentially means I work in a lab, supposed to work in a lab about 20 hours a week, and I'm supposed to teach about 20 hours a week. And that pays my bills, it pays my tuition, and it gives me a stipend to live off of. There are those who are fortunate enough to have fellowships from places like the NSF, the DoD, and the Department of Energy, and some companies will actually fund a PhD as well. But the general consensus is that you're doing research, there's generally funding available to you. And I guess the final point here is that your job prospects are going to be much different with a PhD than it would be with a Master's of Science, or even, or definitely in terms of somebody with a bachelor's degree. Because research is going to become a much more integrated part of your life, and a much more integrated part of your career, which may actually make you overqualified for many positions that you could apply for. So, my average day in a week, what it's like to be a grad student.